Oh, let's see why this isn't working. Burnt power connector right there. Big old 5090. So as we stated in the introduction, here we have a ASRock 5090. Oftentimes when people see video cards, they see this big, huge device. Most of that's heatsink and casing. This is what your video card looks like. This is your GPU. This is a 5090. Actually, from further inspection, I see that not only do we have a burnt pin here, but the port itself is actually tilted off of the video card. Let's look under a microscope. Customer brought this in saying that it wasn't working, and as we can see, yeah, right there on the right hand side we have a broken pin. Maybe we could probably straighten out that pin, but it's just much better for us to just replace it. And also, as you can see, it's kind of tilted as well too. So we're gonna go ahead and replace this connector altogether. Here's our replacement connector. This is a power connector for a 5090. We're going to actually desolder this port. We're going to remove this port, and we're going to actually wick away the solder that's currently there. And the reason being is because with these plastic ports, you want to be very, very careful anchoring them into the board, because oftentimes what can happen is that the plastic casing can melt and deform the port. So what I like to do, and what we're going to do in this video, is that we're going to actually completely remove this port, and we're going to wick away or desolder all of the solder there, so I can actually physically place the port in the actual GPU to make sure it aligns properly. So to get started, first thing we're going to do is we got a little bit of flux here. We're going to put some flux on the back of this connector. Hopefully you can see that. Let's focus that in. We're going to get some flux back here. I'm going to go ahead and get started on removing this guy. We'll put some flux on the bottom side as well. Here's our connections for our port. And we're going to wick away all of this solder as well. Like I said, we're doing this so we can protect our replacement port, and so we don't have to worry about damaging it. This board is fairly thick, so we're going to be going in hot with 500 degrees Celsius at 120 liters of airflow. I put this mark here because I wanted to mark to make sure I didn't get the donor port mixed up with the replacement one. Sorry about that. Okay, let's go in. 500 degrees Celsius. Beam extraction on. Let's get after this. 59 is an expensive video card, so customer's going to want this back soon. So we're going to start applying heat here, and then as you can see, I'm slightly moving the heat because I don't want to concentrate the heat in one area. Oftentimes I like to preheat the board. It makes it easier to desolder. And I've already alloyed the solder as well. So we're gonna just get the solder hot enough, and then we're gonna mix it, and then we're gonna remove it. And we're gonna alloy this with some low melt solder to help make it a little bit better. Let's see if we can remove it. Okay. Wait a few seconds for that solder to cool off. Okay. So the next thing we're going to do is we're going to alloy this solder with some low melt solder. That's just going to help lower the melting temperature, make it easier to wick this away. Come Coming in with our Hacko FM203. Just mix that in a little bit. All that in there, mix that all up. And the whole point of alloying this solder is we want to lower the melting temperature. I'm gonna cut my anti-glare off light off, see if that makes it a little bit. Oh, that looks a lot better. Okay. So you can see what I'm doing here. So now we're gonna get some solder wick. We use MG Chemicals number 453 fine braid. It gets the job done. Sometimes it can be a little expensive, but I've always liked MG Chemicals and the products that they produce. I've been soldering for going on almost 2 decades, and I've always used their products. I always appreciate that. I'll do a whole different video of what I use for flux and other bench tools that I have. So we're just gonna go in here and we're gonna wick away the solder because, like I said, dealing with these plastic connectors, you gotta be very, very careful when it comes to heating up a board and inserting these connectors or anchoring them because these ports will deform. Also, this practice is very good when it comes to even harvesting connectors and ports from other boards as well. Let's go in here, get our extractor on, and let's wick away. And yeah, sometimes you might use a lot of wick during this process, so be mindful. But you gotta do what you gotta do. So just still be mindful of the amount of wick you use. I'm grabbing a pair of tweezers. I'll touch up with my bare hands and you can see that solder, especially since it's been alloyed, is coming out fairly easy. If you're trying to wick away solder and you're struggling, alloy the solder. Mix it with leaded solder or low melt solder. Northridge Fix has some awesome low melt solder products that they have that I bought from them myself. It works really, really well for this kind of repair. Okay. Clean my tip as well. Also another trick, when you're wicking away solder and you're having difficulty, like in these two top naphtha holes right here, add a little bit of solder to your iron, which will kind of help the thermal linkage between said whatever you're trying to desolder. Gotta be patient when it comes to wicking away solder as well. Takes time. Okay, so we got most of the solder out. Still got some there. So what I'm gonna do is I'm going to flip the board over, but before I do that, I'm going to actually use my hot air station. I'm going to heat this solder up again because the hotter the board is, the easier it is to remove the solder, sorry. So I'm going to heat this board back up underneath my scope. Like so, let's get that in position. Let's go back in. Notice I'm moving this heat around, even though this board has been hot from wicking away that solder. Still don't want to thermal shock the board, but I want to kind of reflow this solder. And then actually I'm going to try to remove it from the back side as well. I'm going to flip the board over and try to remove it from the back side. Just got our extractor on so we can save our lungs. And you can see the solder starting to melt and reflow. Okay. Now I'm going to flip the board over on the back side. Okay. Let's get back at it again, wicking away this solder. I'm going to actually mix this in a little bit better just because we've lost a lot. Okay. Go on the front side and remove some more solder. Sorry I had to cut a light on, I couldn't see. That anti-glare light is good for glare, but it's not that good when it comes to looking under the microscope itself. Turn that down a little bit. So low melt solder isn't working as well. I'm gonna clean this up and reheat this board back up and see if I have greater success. Sometimes this happens. Just means that we need probably more heat. Yeah. Going back in with heat. I'm going to add a little bit of solder to some of these holes. I know this may seem counterproductive, but I'm adding leaded solder because I really want to get this solder to really mix. So I can really easily remove it. I know you may say, Juvix, why are you mixing in solder if you're trying to remove solder? Well, the point is that the solder that's here is still a lot of non-leaded solder in these holes, and non-leaded solder takes a lot longer. It takes a lot more heat to melt than leaded solder. So what I'm doing is I'm just continuing to alloy and mix it up. These holes on the bottom, as you can see, they already have solder removed from them. I'm just trying to add a little bit of solder to the holes that are giving me a little bit of a hard time removing solder out. And I don't have one of those solder suckers. One of these soldering sucking pumps. This is all I got. So we're gonna alloy until we can get it right. Maybe I'll invest in getting one of those. All right, let's go back in. I'm gonna put a little more, little solder on my iron. From Baltimore, yeah, we say iron. Iron, 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 iron. When in doubt, chip away. I'm gonna bring out the big guns, the super low melt solder, courtesy of North Ridge Fix. I like their products. I know that looks crazy, but we're about to melt that on down. All right. We're gonna flow this heat after we alloy this low melt solder. We're gonna flow it top and bottom. So first we're gonna come in underneath. Now I'm going to flow over top. And the reason why is because I really want that solder to go all the way through the bottom of the board and on top. You guys can't see it, but I got three big solder balls. And I'm just heating this up as much as possible just to get that low melt through. Now we got that low melt solder there. Now we're gonna try this soldering using wick on the back side. I'm gonna flip this guy over and see what it looks like on the back. Yep, let me see that solder coming right up. That is the whole point of low mount solder right there. If we got a little bit of solder left, that's fine. We'll get it on the other side. sure you keep your teeth clean. Well, it looks like these holes have some solder in them. Just getting rid of that. Okay, we're going to flip this board over. A couple of spots on the front side we want to clean up. Still got a little bit left. Use our hot air to pretty much heat this up and push this solder back up. Got a few pieces of low melt solder. We're just gonna Okay, that looks cleaned up. Let's get this all cleaned up here. Looks good. Just be able to put our new connector in. It's like a charm. One set. On the back side a little bit too. Little trick here, if you got stubborn flux left on the board, heat it up and clean it off. So we got one hole left over. Missed a spot. Okay, looks all cleaned up now. Let's go ahead and put our port in. do is just going to solder one connection to kind of like tack it in place. I'll solder two. Tack it on the other side, and then we're going to flip the board and solder it all the way in. Sorry for the angle, guys. Okay. Now we're going to flip this guy over and solder up the rest of these connections. I'm going to touch each one of these guys, but I'm going to first kind of just flow them all with solder, and then I'm going to touch each individual one to make sure that solder really flowed in there. Well, actually, I can actually use the hot air station from the bottom and make sure that solder flowed upward, but I'll do each one of these guys a few seconds here. Make sure that solder flows all the way up those pins. Gives it a nice, strong, solid connection to the board. And just to make double sure, we're going to check it on this side. And you see how that solder has flowed up on some of those pins. So we're going to heat it up from the bottom. And that should be a job well done. I'm going to move this heat back and forth. Don't want to burn this connector. Be very careful. Do this for about 20 more seconds. And so just going to really make sure that solder really sits in. And as long as I move this connector back and forth, I don't have to worry about, as long as I move this hot air station back and forth, I don't have to worry about burning this connector. Alright, that should be good enough. Give it a few seconds to cool, and then we're going to inspect it again on the other side. Good. right, let's clean it up, and this repair shall be done. Alright. A job well done. That's it. That's all it is to it. So 5090 with a new connector. Now we're going to hand this back over to the computer technician. They're going to put the GPU back together, and hopefully the customer will be good. If you like this content, please consider liking and subscribing to the channel. My name is Juvix. Thank you for stopping by. Take care.